Hello mathematicians, this is 8.3, multiplication properties of exponents. So in your notes you need to write down this, multiplying powers with the same base. So if you have 3 to the 5th times 3 to the 4th, that is going to equal 3 to the 9th. Or h to the 2nd times h to the 9th, it would be h to the 11th. It's like saying, okay, I have 5 of these, and I'm going to multiply 4 more. So then you just add them all up. Sometimes it just really helps to write it out. I still do it sometimes when I forget my rules because there's so many to try and remember. So rewrite each expression using each base only once. So you'd have 11 to the 4th times 11 to the 3rd. You add those together and you get 11 to the 7th. Here you have 5 to the negative 2nd, 5 to the 2nd. That's 5 to the 0 power, which is 1. So try A, B, and C. Okay, this would be 5 to the 9th power. You're just adding the 3 and the 6. Here, 4 minus 3 is 2 to the 1st power, which is 2. And here you have negative 3, you have 2, and then you have 6. So, if you're not seeing this, it would be 2 plus 6 is 8, minus 3 is 5. So you'd be left with 5. Or you could write it like this. I have 2 7s on the top, that's this one. And then I have 6. And then what, did I do that right? Yeah. And then what we learned about negative exponents is they go on the denominator. So negative 3 would be down here. So then these cancel out and these cancel out, and I'm left with 5 on the top. So it's 7 to the 5th. Maybe that helps you a little bit. So multiplying powers in an algebraic expression. So simplify each expression. So now you're going to have numbers and letters. So they're just adding one more thing. So what you want to do is you want to first add the 2 or multiply the 2 times the 3. And then you're going to combine the n's. So this one, 2 times 3 is 6. N to the 5th, n to the negative 2nd is n to the 3rd. And then this one, they are different, but you still can multiply the bases or the numbers. So you do 5 times 2 times 3, and that gets you 30. And then you have x and x to the 8th, which equals x to the 9th. And then you just have the y to the 4th. Nothing happens with the y to the 4th. So try these problems. So here I'm going to have 7. I have 1n plus 2n is 3n's plus 3n is 6n's. So 7 times n to the 6th. Here I have 2 times 2 is 4 times 7 is 28. And then my y's I can combine. There's no other x, so I just write that, x squared. And then y to the 7th. And then here I have 7. I have 3m's over n to the 2nd. Since that was a negative 2 and it was all by itself, I just put it in the denominator to keep it positive. Or you could have written it like this. Same exact thing. Both of those are the same. So, multiplying numbers in scientific notation. So when you're multiplying the numbers in scientific notation, you're using the same exact skills that you just learned. You're going to multiply your numbers, and then pretend these are x's. Pretend that's like an x or a y. And you'd have x to the 2nd and x to the 5th. You'd write x to the 7th, but instead of x, you're going to write 10. So, but then you always have to do that last step where it's changing it back to scientific notation. So try A, B, and C. Okay, so first I'm going to do 2.5 times 6, which is 15. And then 10 to the 8th times 10 to the 3rd is 10 to the 11th. And then I have to move this to make it 1.5. So 1.5 times 10 to the 12th. You're going to add an exponent because you're making your number smaller. So 1.5 times 3 is 4.5. I'm doing my numbers. I'm multiplying the numbers. And then 10 to the negative 2nd and 10 to the fourth is 10 to the second. And this one's nice because it's already done. I don't have to change anything. Here I have 9 times 7, which is 63. 10 to the negative 6 and 10 to the negative 9th is 10 to the negative 15th. Now, if I'm going to move my number to 6.3, I have to add another tens place, so it'd be 10 to the negative 16th. So, a human body contains 3.2 times 10 to the fourth microliters of blood for each pound of body weight. Each microliter of blood contains about 5 times 10 to the sixth red blood cells. Find the approximate number of red blood cells in the body of a 125-pound person. So, what you're doing is you're going to multiply those two together, the microliters of blood for each pound, and then within that, it's red blood cells. So what they did is they multiplied, okay, here's just the blood part. The human body contains about 3 points of blood. And then here is the red blood cells part, and then here is the weight. So they're multiplying all three of the things together. So then you get 125 times 3.2 times 5, which is 2,000. 10 to the fourth times 10 to the sixth is 10 to the 10th. So you get 2,000 times 10 to the 10th. You move your decimal point 3 places. So then you have 2 times 10 to the third times 10 to the 10th, which is 2 times 10 to the 13th in a 125-pound person. So how many red blood cells are in the body of a 160-pound soccer player? So try that one. So you're going to do 160 times 3.2 times 5 times 10 to the 10th. So 160 times 3.2 times 5 is 2560 times 10 to the 10th, and then I'm going to add 3 spaces. So you get 2.560 times 10 to the 13th. All right, that's it for your notes.